10.2 and 10.3 today, but I'll post 2 separate videos to keep them shorter. All right, so we've been focusing throughout the entire year on rewriting mathematical expressions and equations in different forms. And we do this because different forms of an equation allow us to see different characteristics. And sometimes different forms make it easier to work with that number or expression. And this is also true of irrational numbers. All right, so our first thing that we're looking at is rational exponents. And rational exponents is when we have an exponent that is in a fraction, because a rational number is a number that can be written as a fraction. So the first thing we need to know is that when we have an exponent like a raised to the power of 1 over n, what that means is the nth root of a. So our first example for that here is a to the 1/8. So when we see a to the 1/8, what that means is the 8th root of a. I like the pencil better. And this works for roots that are not square roots as well. If it was a square root, so if we did have, say maybe x to the 1/2, that the 1/2 power is the square root, you could still write it like this, but we don't usually write the 2 when the 2 is the root that we're talking about there. All right, so the next one here, b, is the -8 raised to the 1/3 power. So we look at the denominator, and it tells us the little number that we're going to put as our root there, so that's 3. The 3rd root of -8. This one actually could be simplified because -2 times -2 times -2 does equal -8. So this would equal, well, just -2 as our final answer. All right, so rational numbers, again, are numbers that can be written as fractions of whole numbers, and a rational exponent can be rewritten into a radical form. Just like having a number in its radical form, we can rewrite it an exponential form. We can rewrite it as a radical. We could do the same by taking a number that is in a radical form and rewriting it as an exponent. Personally, I find it a lot of times easier to work with numbers when they're in the exponential form. So this first one, if we have a 4 right here, that means the power is the 4th root. So it's x to the 1/4. And there's nothing else we can do to simplify that. 3 here, so it is 27 to the 1/3. The 1/3 power is the same as the 3rd root. So again, we're looking for numbers that multiply together to give us 27. If we do 3 times 3 is 9, times 3 is 27. So 3 times 3 times 3 does equal 27. So the 3rd root of 27 simplifies to 3. All right, so sometimes we have a power on the value that's inside the radical, and what that is going to be written kind of like this. So we've got 8 squared raised to the 3rd, 8 squared, and it's the 3rd root, y squared, the 3rd root of that. Well, we're going to use this idea here. The denominator of the fraction is what we're putting on the radicand on the outside there, and the numerator is the power. So when we have the 3rd root of y squared, here is our numerator, and that's our denominator. So we would have y raised to the 2/3 power. The numerator is 2, and then the denominator 3. All right, so this one we've got 8 squared. We could just multiply that out and get 64. But this is an example of where rewriting it could be helpful. All right, so this would be 8. The numerator is 2, and 3 is the denominator. So it's squaring the 8 and then taking the cubed root, or take the cubed root of 8 first and then squaring it. Cubed root of 8 is 2 because 2 times 2 times 2 equals 8. So 8 to the 1/3 equals 2. So I'm going to apply that first. So this would be the same as 8 to the 1/3 and then squared. I'm actually jumping ahead to our power to a power. 8 to the 1/3 is 2, and then 2 squared is 4. So I did kind of use an idea here that's actually the next thing, and that is that exponent rules still apply. So back when we were just using whole number exponents, if we had x to the a times x to the b, well, that was x to the a. Whoa, that really did not write very well. I apologize for that. X to the a plus b. So for example, if we had 3 squared times 3 to the 3rd, that would have been 3 to the 2 plus 3, or 5th. And then also power to a power. That is when we multiply those exponents. This would be x to the a times b. As an example, if we had 3 squared raised to the 3rd power, we know that that would be 3 to the 6th. All right, so power to a power, we multiply the exponents. When we're multiplying two powers, we add the exponents. That's what we have here. X to the 3rd times x to the 6th is going to be x to the 1/3 plus 5/6. Do a little work on the side here. 1/3 plus 5/6. We need common denominators. So that would be 2 over 6 plus 5 over 6, or 7/6. And that would be x then to the 7/6. And here we would have 2 to the 1/4 times 2 to the 1/2. So that would be 2 to the 1/4 plus 1/2. Do a little work on the side. 1/4 plus 1/2. So that would be the same as 1/4 plus 2/4. And that's 3/4. And so our final answer would be 2 to the 3/4. So again, we can simplify when we have the same base. The key here is these were both 2's. And these were both x's. As long as the bases are the same, we can apply those exponent rules. All right, power to a power, that's when we're going to multiply those exponents. So we're going to multiply the 2 times the 1/5 and the 3 times the 1/5, and we're going to get x to the 2 times 1/5 is 2/5 times y to the 3/5. Just multiplying and applying that exponent to both. Sometimes when we do that, it'll simplify a little bit. So if we do this again, we're going to have 2, and then apply that by multiplying the power to a power. So it's 2/3 times 6/5. So multiply straight across. We're going to get 2. 2 times 6 is 12. 3 times 5 is 15. And we'd have to check to see, can that be reduced at all? 12 over 15. Let's do this on the side. 12 over 15. That's the same as 4 times 3 over 5 times 3. So 12 over 15 is the same as 4/5. So 2 to the 4/5 power. All right. And then continuing on with our exponent rules, when we have a power divided by a power, we would subtract the exponent. So this would be x to the a minus b. So we'll do the same thing here. We're going to have the same base, so it's x to the 5/6 minus 1/3. And then do some work on the side here. 5/6 minus 1/3. Need a common denominator. 5/6. Multiply by 2 over 2. It's 2/6. So 5/6 minus 2/6. Well, actually, that works out to be 3/6. And 3/6 is 1/2. So that's kind of convenient. So that works out to be x to the 1/2. And if we were asked, which it didn't say, to write this as a radical expression, this would actually just be the same as the square root of x, because that's the denominator is 2, the exponent is 1. It's just kind of going back to what we were talking about there. Okay, The last part for section 10.2 is simplifying when we have these radical expressions, and we can do that by turning this radical expression into an exponential one. Rewrite it. So here's our numerator. Here's our denominator for the exponent. So that's going to be x to the 2/8. 2/8 reduces, so that's just x to the 1/4. And then this next one, we've got the numerator is 3, denominator is 9, so that is 8 to the 3/9, and then that's going to reduce. 3/9 is the same as 1/3, and we've seen a couple times already that 8 to the 1/3 is just 2, because 2 times 2 times 2 gives us 8. And then this one here, square root. We got to remember that even though it's not written there, there's a little imaginary 2 that we can, not imaginary, but invisible 2 that we have there. So our numerator is 2, and our denominator is 10. I know it seems strange that I'm saying there's a 2 there, but keep in mind, we see stuff like that all the time. If we were doing, oh, that's fancy. If we were doing like 2x plus x, well, we don't see a 1 there. Let's go back to a normal color. But there is a 1 there. So even though it wasn't written, it's there. We just know that the standard notation for a single x is to not write the 1. Well, it's the same thing. The standard notation for this symbol is that there's a 2 there. We just don't have to write it because it's standard. All right, so our numerator is 2, denominator is 10, and so that's xy to the 10th. So we'll write it as xy to the 2/10. Well, 2/10 is the same as 1/5. So xy to the 1/5. All right, and that will be section 10.2. I'm really sorry for going so fast, but pause it anytime you need. Right now, I would suggest go into my math lab and do the problems for section 10.2, and then come back and watch the next video for section 10.